Hi everybody. I'm going to explain you what is a PowSyBl project. So PowSyBl stands for Power System Blocks. It's a Java library. It means that we are playing Lego with power systems. PowSyBl makes it easy to write complex software for power system calculations. In the high-level architecture theme, it is the top right box explained by Benoit yesterday. It makes it easy to extend and customize its feature through its modular approach. It means that the basis is available in PowSyBl, but you can almost do what you want around the network with our library. The open source community involves 50 people, and it increases days after days. So in more details, here are the main blocks. We provide a grid modeling, a complete, all the components are modeled in our grid. And as I said before, it is fully editable and extendable. So for example, we provide transformers modeling, and you can extend with almost what you want. For example, the brand, the year of building, something like that. We also provide power flow simulations, such as load flows, security analyses with or without remedial action, sensitivity analysis. Next year, we have planned to integrate dynamic simulation through our open source tool called Dynamo. I don't know if you know, but it's a big project of RT, and maybe Luchan can talk about it during the break. We also provide with the PowSyBl advanced features such as Python binding, HPC support, some time series, and some scalable data management. If I've forgotten this box, we also support some exchange formats. For example, the official exchange format in Europe is UCTU, and we can deal with that format. We are working on the SIM-CGMS format on the 42 TSOs. So it will be, I hope, available next year. Here you can test our beta version. And okay, if you want to learn more about PowSyBl, we have a pedagogic section in our website, which explain you what user stories we can tell with PowSyBl for TSOs or for RSCs. RSCs are regional security centers. And a contribute section, but you know it. So what can we do with PowSyBl? It's a short example. You can use just a few blocks, and it's quite a simple workflow, so you can upload a file, for example, a CGMS or a UCTU file. You can run a load flow. It means that you compute the flows on the network. You can then simulate a contingency. For example, a contingency can be the loss of a generator or the loss of a transmission line. And then you rerun a load flow to see the differences with the previous state. and then you can see where you have to look in your network during operation, not to have a secure operation. With with almost the same blocks, because they are the same blocks, you can build really more complex workflows. Here is a workflow to forecast the secure operation of the grid. This workflow will be in operation in RT next year, I hope. Here you upload a file, then you run what we call a security analysis, which is in fact the simulation of all the contingency we can met in our network. And for the contingency where we met limit violations, we can simulate action, remedial action, and then we run a load flow to see if it solves the problem. In dark blue, you can see the specific code needed to build this workflow. And in light blue, it is the possible library. Okay, we can increase some specific code around PowSyBl to have a more complex workflow. For example, this workflow is used to compute the coordinated cross-border power exchange capacity. Here you can upload all the CGMS file of the European network. You can do a merge. It means that you are building the pan-European network. Then you can run a load flow. And here in dark blue, we can build an optimization based on the sensitivity analysis block of PowSyBl. This, the optimizer is specific, and some file can be uploaded to in a specific way. And if you want more details about this workflow, the project is called Pharaoh, and we have a website, and it's available on PowSyBl website too. And you can find the best set of action to increase the cross-border capacity. And a final workflow. For this workflow is for grid planning. So you can assess the cost and the benefit of investment for grid planning. And in this approach, we use what I presented before. It is we use the time series, and the time series allow us to have a stochastic vision of power system calculation. And we are doing what we call a mapping. A mapping is, for example, you can map to a generator several scenarios to explain what could happen in the future. And we use after that what we call an optimal power flow to say what we have to do to reinforce our network. I think it's all. Yes. So that's all. I hope you enjoy the presentation.